Well, welcome. Thank you so much for coming out. What I'm going to do here is, as Redbeard said, we're going to be walking through, talking about where this technology that we've all been working on, this Google-like infrastructure, has been over the last few years, where it's going, walk through some announcements, some new stuff that we've been doing, both in our open source projects and in some of our products, and also encourage you to get involved. A lot of the hope of bringing us all together here in this one place is that we can share ideas, get inspiration, and figure out how we're actually using these technologies together inside of our systems. All right, so when we started CoreOS, we had a mission in mind. It's a very daunting mission, which is to secure the internet. I don't think we'll be completing this mission anytime soon, so I imagine that we'll be having these events for years to come. And part of this mission, we had in mind a particular strategy. And that strategy was to drive and accelerate the adoption of these technologies that we believed could secure the internet. Technologies that would help people run their server infrastructure in a more consistent and reliable manner. And in order to get those into place in production environments, we needed to do that through open source. Primarily because this is a very humbling mission. Securing the internet, a place where people spend their time communicating, doing commerce, is a grand task, and it requires the cooperation and combined effort of all of us. And then the other part of this strategy was that we had this goal in mind that we'd be able to work with people that we really enjoy working with. And there are dozens in this room who've contributed to the open source projects that make up CoreOS and the other projects around the ecosystem, Docker and Kubernetes and Linux, et cetera, that you'll be meeting over the coming days. And I know there's many of you who have ambitions to get involved, and I hope that I can inspire you through the next few minutes to find places that you may be able to contribute documentation or actually use these things in your production environments, or perhaps even do some code. So we've had pretty good success so far at this overall strategy. We've had thousands of people across the globe who've contributed to CoreOS projects. And I wanted to call out a few who've done a lot of great work over the last few years. Simone Gatti, who I've never met before, he rewrote large swaths of Rocket that I initially wrote. So huge thanks to Simone. I was really looking forward to meeting him. Unfortunately, well, fortunately, he just had a new son yesterday, a newborn son. Round of applause for that. So he sent us an email saying he's still reverse engineering his son, and so he'll be busy with that over the next few weeks and months and 20 years. Another contributor that I wanted to call out was Fruda, who worked on LDAP support in DEX. And DEX is this piece of technology that we introduced that bridges OpenID Connect, which is this internet identity protocol that's used by Google and GitHub and Facebook, with the world of enterprise identity, LDAP. I'm also really looking forward to meeting him because I'm sure I just butchered his name. So if he's in the audience, I haven't seen him yet today, thank you so much. Round of applause, thank you. Another person I wanted to call out was Julian, who has worked on Claire. In particular, he'll be giving a talk about his integration with Claire through a command line interface and proxy that he's built called HyperClaire. And finally, Hitoshi Mitaki, who's going to be giving a talk today or tomorrow about etcd and the work that he's been doing to add v3 authentication support. So I want to give a round of applause for all the folks that have been doing great work inside of these projects. And then, of course, I look forward to meeting all of you over the coming days, and I hope to see similar successes over the next few years as we continue on this mission of securing the internet through open source software. I also wanted to take a brief moment to thank everyone here at the convention center, all the staff that have been running the lights and running the video and running the event booths, and the CoreOS staff who have traveled from New York and Berlin, well, not very far from Berlin, and San Francisco to make this event possible. And of course, all of you for coming here. So a round of applause for everyone who's come out today. All right, so let's do a brief timeline of how we got here in this room. So 3 years ago, none of this really existed. We had a lot of proto-technologies that thought about these technologies and how they come together. We had a lot of inspiration from large industry leaders that run their infrastructure in this way, the Google and Facebooks and Twitters of the world. And then about 2.5 years ago, we started this conversation as an industry around how we might take these white papers, these rumors that we've heard about how these large internet companies run their infrastructure, and how we could bring them into open source. A big part of this was the introduction of application containers, so actually packaging up containers not as lightweight VMs, but as individual processes and running them through the introduction of the Docker engine. This was a big part of that initial conversation. Thinking about how we redesign the Linux server operating system with the introduction of CoreOS Linux, and then bringing distributed systems into an easier, making distributed systems easier for folks with things like etcd. And then about 1.5 years ago, we started a conversation through our work with AppC, which brought together a number of people in the industry to think about how do we standardize these container images. It's really important as we imagine this style of infrastructure growing over the coming decades that we ensure that things like the build systems and the runtime systems and the systems that ship around these container images are all able to interop. And so we started this conversation with AppC, and this conversation continues to go through the work in the OCI, which I'll talk about later. And then also about how these container runtimes might be built in different ways with different focuses on security through the introduction of Rocket. Thinking about novel new ways of isolating these containers with things like virtual machine isolation of the containers, privilege separation using Unix processes, and these sorts of basic fundamental ideas of security. And then 1 year ago, we got the introduction of Kubernetes v1.0. This is a huge moment in how this style of infrastructure has been evolving in the open source. Google took essentially what they had learned with Borg and introduced into the open source community a next generation Borg that they called Kubernetes. And this is relying upon all these technologies that were built up before it. Things like container images, etcd, et cetera, to bring together an API and a system that was inspired by the systems that run huge swaths of Google today. And then today, we're hearing more conversations, not about these foundational technologies and how we might bring these technologies together, but how we're going to take these technologies in production, how are we going to ensure that these technologies scale, and then how do we secure these technologies as we put them on the open internet and they encounter real world situations. So it's moving less, and we're talking less about the foundational technologies and more about how do we make sure these things are operatable in production. All right, so that kind of sets the stage of where we've been and how we made it into this spaceship-like event room. And so let's talk about some new technology, some new updates from the open source projects. So the first thing I want to talk about is etcd 3 beta. etcd 3 is the next edition of etcd. We've redesigned a lot of things of the internals of etcd, introduced new APIs, with the goal in mind of being super efficient and very scalable. So the first thing that we do while we're getting ready for this etcd 3 release is we do a bunch of very punishing functional tests to the etcd clusters. And the idea here is that we're trying to make etcd very unhappy. Okay? And the idea is that we're running these punishing tests. If you've ever been in IKEA before, you have the chair, and the chair is being poked by a mechanical machine. Similar idea with etcd here. We want to ensure that we're poking etcd, we're introducing network partitions, we're killing individual processes, killing the entire cluster and bringing it back up, introducing latency, doing things that etcd may encounter in the real world, but doing those things several times a day, actually tens of thousands of times a day in our functional testing clusters. All in the hopes that etcd remains very happy when it encounters these events inside of your production environments. So through the course of etcd v3, we've been doing months and months of these functional testings, getting less and less failure rates as we move forward. And we're down to about 0.01% failure rate with hundreds of thousands of test iterations ran. This new API that we introduced in Etsy v3 is based on gRPC. If you're not familiar, gRPC is an open source protocol that was pulled out of Google, inspired by their internal protocol called Stubby, and it's based around protobufs and HTTP2. By using protobufs over JSON for most applications, you see about a 4x decrease in CPU complexity and memory complexity and just encoding and decoding the actual payload for the request. I always joke that the heat death of the universe is going to be caused by just one more JSON decoding happening. And then we use HTTP2, which allows for lots of concurrent requests to happen over the same TLS connection, which even further greatly reduces the amount of memory and CPU used by etcd in production environments. We also have introduced a new storage engine. This new storage engine does things to ensure that etcd remains scalable in large environments with lots of keys. And not just scalable in the sense that it's memory efficient, but also scalable in that it provides a really, really reliable latency graph. And we'll talk about that later today during the introduction to etcd talk. And the entire goal is that etcd v3 is able to support Kubernetes clusters up to 5,000 machines and beyond. And I want to make a note for the folks watching at home in San Francisco. This slide has been localized. Kubernetes scales past 5 machines. That's 5,000 machines. Beta of etcd v3 is available today. You can get involved at the GitHub project, github.com/coreos/etcd. And there's builds available for Windows, OS X, Linux, and then, of course, containers. If you want to learn more about etcd v3, you can see the introduction talk at 9:50 a.m. All right, so the next thing I want to talk about is Quay Cuddle. We're introducing a new way of transporting images from our Quay container registry based on BitTorrent. So I want to get a show of hands. Who has used BitTorrent at work? Don't worry, the cameras aren't on you. Who has, keep your hands up, have you legitimately used BitTorrent at work for work purposes? Okay, okay. About half of the hands stayed up. Round them up, no. So what we're doing with Quay Cuddle and by introducing BitTorrent as a transport mechanism is we're trying to solve this problem that people have of it takes forever for my container to start. The 800 megabyte Nginx hello world example. And so what happens in containers today is that we have all these layers, and these layers are designed to be cacheable. And the idea being that when you're pulling down different images, you may be able to use the same layer across different images. In practice, this has a couple of consequences. One is that you're making lots of round-trip requests off to the registry that you're pulling these images from, some of which can be really wasteful. You can have requests that add a symbolic link, and so you make an entire HTTP request to download 32 bytes. And so what we're trying to do here is find ways of making this more efficient. So the first thing that we did about 8 months ago is we introduced the idea of squashed images into Quay. So instead of making all these round trips for individual layers, you would squash all the layers down into a single thing. And this also had an added benefit that you may actually have to download less data. Imagine that you have a base image that comes from Debian. That Debian base image has bash, and then you have to upgrade bash in a subsequent layer. By squashing it down, you're not duplicating the transport of multiple copies of things that may be updated in additional layers. And so we've seen by just introducing squash layers that there's savings of about 10 to 50% on most images. And so with Quay Cuddle, what we've done is we've created an out-of-band process, this command line tool, that interacts with both the Rocket engine or the Docker engine, and acts as a BitTorrent client, downloading these images off of Quay, and then putting them into the image store of those engines. The basic idea is that today, every single machine that's inside of your deployment has to talk to Quay directly to get every single layer, all the metadata, et cetera. Instead, what will start to happen by using Quay Cuddle and BitTorrent is that The machines will actually be able to coordinate without going across your gateway to the internet to find the vast majority of the information required to make the image layer, share amongst themselves, and then end up in a place where they have the complete image with very minimal transfer happening to the registry. So Quay Cuddle is in preview today. It's available on our hosted Quay.io instance, and then also downloadable, the actual command line tool is downloadable from github.com/CoreOS/QuayCuddle. If you want to learn more about how this is done, how do we authenticate this stuff, the design decisions that went into the engineering behind this, you can see the talk today at 2:20 in room B08. All right, a new open source project that we're also introducing today is JWT proxy. This is for service-to-service authentication. And it doesn't really matter the size of the service. All services should be authenticated. So if you perhaps have microservices, those can also use JWT proxy. We may have nano services or even smaller services. But the idea is that JWT proxy can be used as a way of authenticating when you have one piece of software that isn't tied to a human being talking to another piece of software. And so how did we get here? Why are we building this JWT proxy? Well, it started with the security scanning inside of Quay. The security scanning is implemented through an open source project we introduced called Claire. And as a quick reminder of what Claire is, Claire takes a database that we collect from various sources on the internet, takes a database of known vulnerabilities. So for example, there's this vulnerability called Ghost that came out a while ago, and like all good vulnerabilities these days, it has a really cool logo. And what Claire does is it looks through all the container images that are in the Quay registry, and it starts to read the metadata and figure out perhaps there is a ghost inside of the image. And if it does, then it's able to communicate through its API with Quay and send you an email or give you a warning through the user interface. But we had this problem in that we had all these different Claire workers that we wanted to hook up to the Quay enterprise primary API, and we wanted some way of authenticating these. But we had a number of constraints because these workers are being deployed in various environments that may be hostile to TLS certificates or that may be hostile to various different types of load balancing configurations. And so we needed a way of securing this in different environments. And we had a bunch of different services that we wanted to authenticate in a similar way. So we have build services that talk to Quay, take source code and transform them into container images. We have the BitTorrent tracker that was just introduced that we need to authenticate as well against Quay so that it can pull the metadata required. And so what JWT proxy does is it uses standard HTTP auth headers, and it puts inside those headers assigned JWT, a JSON web token. The design is such because we need to negotiate different types of load balancers that may man in the middle, rewrite requests, and auth headers seem to be the only thing that can survive most of these types of load balancers that are found in various enterprise environments. And we also wanted to remain compatible with TLS. Many people have TLS environments. They may even have mutual TLS authentication. And JWT proxy can remain compatible with this. But we needed a layer that was underneath that, because a lot of environments, they don't necessarily have the tooling or the institutional expertise to deploy, say, client certificate authentication. So if you want to learn more about this, you can see the talk tomorrow at 9:50 a.m. It's again in B08. And if you want to get involved in the open source project, there's a lot to do. This is a brand new open source project. Things like documentation, proof of concept, and example code, et cetera, is all places that need help. You can find this project at github.com/CoreOS/JWT proxy. And we hope that this starts a conversation about how do we, in a very flexible way, start to authenticate all these little services that we're adding into these environments and make those fully secure systems. All right, and just as an aside, when we introduced Claire into Quay, we ran it against our public registry. And what we found was that this ghost vulnerability about 66% of the container images on the public registry have that vulnerability in them. So I think this is a good, gentle reminder that we have a lot of work to do in how these systems are built, how we learn about the systems before we run them into production, et cetera. And if you want to get a sense of how this whole thing works, you can check out the security scanning inside of Quay.io. You can look at any public image and see what vulnerabilities may be there. Or if you want to see images that you have behind your firewall, you can try out Quay Enterprise that also has security scanning support today. If you want to learn more about that, you can check out quay.io/plans for information. The last piece I wanted to talk about today is the Open Container Initiative. So about 1.5 years ago, we started this conversation around standards with the app container format and spec. And then about 11 months ago, we came together with a bunch of different industry partners, CoreOS, Docker, Microsoft, Red Hat, Google, many others came together and started a conversation and an initiative around how do we actually get in a room and standardize these really important interfaces like the container image. And so I'm really happy to say that over the last about 6 weeks or so, we've gotten together in a new project called the OCI Image Format Spec. And we have maintainers, again, from companies like Google and Red Hat and CoreOS and Docker and Microsoft coming together to figure out what is a unified spec that we can have that brings together the best of the Docker image format and the AppC format and blends them into something that the entire industry can get behind. Now we're making really good progress here. We had an initial release of this image spec last week. Our hope is that we get to a 1.0 over the coming months, and that container registry support through Amazon Container Registry, Google Container Registry, Docker Hub, Quay.io, and all the other open source registries out there starts to emerge. So if you want to get involved here, I think there's a lot of interesting work that needs to happen. The OCI image spec, like I said, has just hit the V01, the very initial release. And it has some of the initial foundations that we need in order to get this thing to 1.0. But there's much to do in essentially battle testing this thing, porting build systems over to this new format, improving the documentation based on how people actually read from top to bottom. Many of us working on the spec are a little too close to know whether the documentation is bad or not. So if you have a passion for ensuring that this entire ecosystem remains viable over the coming decades, this will be a great place, and much help is needed. If you want to learn more about this spec and kind of the evolution of how we got here, you can see a talk by Vincent Batts today at 1:30, again in B08. All right, so what we talked through over the last few minutes are the ways that we are going from the foundation that's been laid over the last couple of years, things like etcd, containers, Kubernetes, CoreOS Linux, and how we're actually preparing and getting these things ready for production, scale, and with really good security in mind. There's a lot of work to be done. There's a lot of new open source projects that we've introduced here today and that will be introduced over the coming days here at CoreOS Fest. And I hope that over the coming months and years that we will continue to find new people that we love to work with, such as yourselves, and that you'll join the overall open source community around CoreOS and this entire way of running infrastructure that's emerging. So with that, I hope you enjoy the next 2 days at CoreOS Fest. It's our pleasure to have you here. I can't wait to meet you all, and thank you.